In this video, we'll be sketching quadratic functions. A quadratic function is a function that has a number in front of x squared, a number in front of x, and a number on the end. And a quadratic function gives me the shape of a parabola. Now, it can open in this direction if the number in front of x squared, which is the coefficient, is positive. If that's a positive number, it will open up. If it is a negative number, it will open downwards. So when we are sketching, this is a good way to look at which direction our quadratic function needs to go. In this example, we have x squared minus 6x plus 5. And whenever I'm sketching a quadratic function, I need to make sure that I get three important points. The first point is the vertex. The vertex is the turning point of the parabola. That is my first important point I need to get. Then I need to get the y-intercept. That is where it is intercepting the y-axis. And then I need to get the x-intercept, where it's intercepting the x-axis. So those are the 3 points that I need to focus on. So we will start focusing on the vertex, the turning point of the graph. In the vertex, we have 2 points. The vertex is represented by an x and a y value because it is a point on the graph. The formula in order to get the vertex, to get the x value, is x is equal to minus b over 2a. If we can input the values of b and a into this formula, we will get the x value of the vertex. Well, a is the number in front of x squared, b is the number in front of x, and if we had to use c, it would be the last number here. But we are only looking at a and b. So by inputting the values of b is a negative 6, so whenever I substitute, I put it in brackets, divided by 2 times a, which is 1. And in this case, I get out the value of 3. 3 is the x value of the vertex. And now I need to find its matching y value. And because I have a function, every x value has a y value. And how do we do that? We substitute that back into the function. So wherever I see an x, I should replace it with the number 3 and I will get its matching y value. So we substitute back in and my y value will be equal to 3 squared minus 6 times 3 plus 5. I put that into my calculator and I get 3 squared minus 6 times 3 plus 5. And that would give me negative 4. So my vertex is the x value of 3 and the y value of negative 4. I can put that on the graph now. So my x value of 3 is over here, and my y value of negative 4 is down here. And therefore, my point will be there. That is my vertex. The next one we need to do, now that I have my vertex, is to find the y-intercept. I am looking for the y-intercept, so that is the y value anywhere along this line. And if I look at the x value along that line, the x value will always be 0, no matter where I am on that line. So I can use that fact to find the y-intercept. To find the y-intercept, we have to make x equal to 0, because x will be 0 everywhere along the y-axis. Everywhere along this axis, x will be 0. Therefore, when I'm trying to find the y value, I input 0 into the x value, and I notice that I'm left with the value of 5. That is the value on the end. All of this will be 0, 0, and I'm left with y is 5. Often when you are taught how to sketch, you will just be told that the last value, the C value, will always be the y-intercept. But you need to understand why that is true. That is true because by inputting a 0 for x, I will always get the last value of my quadratic function. So in this case, my y value, my y-intercept is 5. The x value is 0, the y value is 5. Now I'm going to try and find the x-intercepts. I've found the vertex, I've found the y-intercept. Now I'm going to look at the x-intercept. So, the same idea as I was using for the y-intercept, I will look for the x-intercept. So all along the x-axis, I know that the y value must be 0. Therefore, I can use that fact to find out what my x-intercepts are. So, by making the y value 0, I am left with x squared minus 6x plus 5. And now I am solving a quadratic equation. There are many ways to do this, but the way we are going to do it is by factoring. Now, I have a video on factoring trinomials that you can watch, but how we are going to factor this trinomial is the method that I use. That means I need to get this into two brackets. And the method I use in order to do that is the reverse of expanding, where I take the factors of x squared. The factors of x squared will be x and x. I take the factors of 5. That would give me negative 6. Therefore, that would be negative 5 and negative 1. And by multiplying across this way, I'll be able to get the inner terms, just like I was expanding. And I would get minus 5x minus x, and together that makes minus 6x. Now, if that works out, which it does, I check that that number, the middle term is the same, I know that these two things will be my brackets. So in the bracket I have x minus 5 and I have x minus 1. Now we have to solve for x. And if I have two brackets, I've got a bracket here multiplied by another bracket, and that is equal to 0. That means one or both of those brackets should be 0 for the equation to be true. Therefore, x minus 5 should be equal to 0, or x minus 1 should be equal to 0. I add 5 on both sides and I solve for x. In that case, x is equal to 5, and I add 1 on both sides, and x is equal to 1. So as the y value is 0, the x value would be 5 and 1. That means that those are the x-intercepts of my graph. So I would go and sketch the 2 points on the x-axis, where y is equal to 0, x is equal to 1, and x is equal to 5. Now I have got all 3 of my points. Even though the x-axis has 2 points, I've got the vertex, the y-intercept, and the x-intercept. If you've liked this video so far, please remember to subscribe to the channel. The more the channel grows, the more videos I can make. Now we are going to sketch this graph. I have all of the points that I've wanted to sketch, all of the important points, and I will draw a line through the y-intercept, the x-intercept, the vertex turns there, and back through the other x-intercept. And that is how I would sketch my graph.